Today we are covering load factor and performance limits for the FAA Part 107 exam. The test will absolutely require you to understand load factor, which is the stress or G-force experienced by the drone's structure during maneuvers. While a drone in straight and level flight has a load factor of 1G, this number increases any time it deviates from that path. The most critical number to memorize for the exam is related to bank turns. At a 60-degree angle of bank, the load factor is 2Gs. This means the effective weight of the drone on its own structure has doubled. An exam question will present this as a scenario. A drone weighs 10 pounds. During a 60-degree level turn, what is the total load the aircraft structure must support? The answer is 20 pounds. The FAA loves to test this concept because steep turns and aggressive maneuvers significantly stress the airframe, motors, and propellers, exceeding the manufacturer's specified load factor limits, especially on drones with stiff, rigid frames, can lead to in-flight structural failure. A common exam trap involves confusing the concepts of weight and load factor. The drone's physical weight doesn't change, but the load it must support does. Any maneuver other than straight and level flight increases the load factor. The exam will test your understanding that aggressive sport mode flying, especially when combined with strong wind gusts, can create unexpectedly high G-forces. This brings us to performance limits. The performance charts and specifications in your drone's manual are not absolute. They are based on a standard atmosphere at sea level. You must mentally adjust these figures for the actual conditions on the day of flight. The exam will test your knowledge of density altitude. High density altitude, caused by high elevations, high temperatures, or high humidity, means the air is thinner. Thinner air degrades performance. Propellers are less efficient, and motors have to work harder to generate lift. An exam question might describe a flight in a hot, high-altitude location and ask about the drone's performance capabilities. In these high-density altitude conditions, the drone has less performance margin. A steep turn that would be safe at sea level could now exceed the drone's ability to create enough lift, potentially leading to a stall or loss of control. A simple mnemonic to remember the key load factor is bank to 60, double the weight quickly. This links the 60-degree angle directly to the 2G load. Remember that performance charts are a baseline. Always consider how density altitude, the drone's current weight, and wind will reduce your actual performance envelope. The exam expects you to connect these ideas. A steep turn creates a high load factor, and high-density altitude reduces the drone's ability to handle that load. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.